Hello students, this is our second lecture on the control system. In this lecture, we will discuss on the different type of the control systems. So look at this, there are two main type of control systems, that is open loop system and the closed loop system. So now, what is the open loop system? So first consider this block diagram of the open loop control system. Actually, in control system is an interconnection of different components such as the input, controller, plant, output, like this, which gives the desired response. And in open loop control system, this is the reference input. If we consider this is the disturbance is present, maybe disturbance is not present over here, and this one is the control output. And this control variable is permitted to vary in accordance with the inherent characteristics of the control system, and the output of the controller will force the system to give the desired response. So what is an example of open loop control system? Suppose we are walking on a road with the closed eyes. That means here the eyes is act as the sensor, and no sensor is present in this system. And when there is no sensor is present, that means according to the reference input, the output will be changed. Now, as there is no disturbance in the system and there is no sensor is acting in this system, so when we close our eyes, it is very difficult to walk on the desired path because of the absence of eyes, which is used to measure the actual path, that is the desired output, and compare with the desired path, that is the reference input of the system. So another example is the bread toaster. So in the bread toaster, if we want to toast a bread to a desired color, then the desired color depends on the time set of the toasting, and the desired color or the timer knob represents the input quantity and the degree of the color of the toasted bread as the output quantity. And if the degree of the color is not satisfactory due to some reason, then this condition cannot be changed automatically because there is no sensor is used. Another example we can use that when we are driving a car, and to achieve the desired speed we need to give the pressure on the accelerator pedal, and the car starts to moving at the desired speed. But if there are some disturbance like road conditions or the wind velocity, then the speed of the car can deviate from the desired speed, and the car does not run at the desired speed even though there is no change in the pressure applied to the accelerator pedal. And this is distinguished characteristics of an open loop system is that it cannot compensate or take the corrective action for any disturbances that affect the system performance. So that means as per the reference input, the output is changing, and whether disturbance is present, then it is also changing with respect to disturbance and the reference input. So the main advantage of this open loop system is actually it is much simpler and less expensive, as no sensors are needed to measure the variables to provide the feedback. But there are some disadvantages. That means there is no accuracy, as there is no feedback path, so we cannot control the input as per the desired output, and there is no compensation for any disturbance entering into the system since the input is independent on the disturbances. And the next one, the performance highly depends on the properties of the systems, which may vary with respect to the time. So this one is the basic, that is the open loop control system, and the next part, that is the closed loop control system. And in generally we use in maximum cases, that is the closed loop control system. So this one is the block diagram of the closed loop control system, in which the output response, that is this one is the control variable, is measured and it is compared with the reference input, and reference input act as the desired value is given to the controller. Now the controller output minimizes the deviation between the reference input and the control variable. And if there is no difference between the desired value and the control variable, the error becomes 0 and the controller does not take any corrective action, and the output of the control system is maintained at the desired response. So here we can use as an example in open loop control system, the example was walking on a road with the closed eyes. Now consider walking on the road with the open eyes. That means in this case the eyes are open, that means sensor is present, and when the sensor is present, then we can directly compare the reference input with respect to the output, and according to that the error will be calculated, and when the error will be calculated, the controller can take the corrective action. So this is an example of the closed loop control. And another example, suppose we are driving a car at desired speed, and the driver compares the speed of the car with the desired speed, and if he finds any deviation in the speed from the desired speed due to some disturbances, then he can change the speed by increasing or decreasing the pressure on the accelerator pedal, so that the deviation becomes less and finally it goes to 0. In this case, the pressure applied on the accelerator pedal is the controller output. So what are the advantages of closed loop system over the open loop system? Now the closed loop system, it can be designed to provide the extreme accuracy at a steady state. Its time response can be adjusted by appropriate design, and the transient response and the steady state response, which can be controlled more conveniently and with more flexibility, and the less sensitive due to the parameters variation. But there are some disadvantages of closed loop system, that is due to the presence of the sensor, it becomes expensive and it becomes more complex, and the gain of the system is reduced in this closed loop control. And if the closed loop control system is not properly designed, then the feedback system may lead the undesirable response. We are discussing about the major configurations of the control system, that is the open loop system and the closed loop systems. Now consider the more type of feedback control systems depending upon the purpose of the classification. So first consider the linear system and the non-linear system. Now a system, if it obeys the superposition principle, then it will be said as a linear system, and if it doesn't obey the superposition principle, then we can say the systems are the non-linear systems. So according to the method of analysis and design control systems, we can classify these as the linear control and non-linear control system. So next, depending upon whether the parameters of the system are constant with respect to time or not, that is known as the time variant and time invariant system. So the circuit constants are not changing with respect to time, then it is called time invariant, and if it changes with respect to time, then it is called the time variant system. Next is the according to the order of the system. So order of the system, that means the differential equations of the system, and the order of the differential equations may be 1, 2 or 3. So as per that we can divide the system into first order system, second order system, like this, or maybe nth order system. And for the next one, this is the SISO and MIMO. That means single input, single output, and multiple input, multiple output system. So depending upon the number of inputs and number of outputs, we can classify in this way. Next is the underdamped, damped, critically damped and overdamped system. That means here we are classifying the system as per the damping of the system. And the last, that is the continuous and discrete type of system. That means according to the signals used in the system, we can say, or we can classify the system as the continuous and discrete systems. So for the linear and non-linear system, if a system obeys the superposition principle, then is said to be the linear system. So here we are considering two systems. For the system 1, the input is x1 and output is y1, and for the system 2, the input is x2 and the output is y2. Now according to what is the superposition principle? So superposition principle is the summation of law of additivity and law of homogeneity. So law of additivity means if the two inputs, actually this system 1 and system 2 both have the same transfer function, or we can represent both by same system, and two different inputs are used and two different outputs are coming. So for the first one, the x1t is applied and the next one x2t is applied. So if we give the summation of these two inputs to the system, then according to the law of additivity, the output should be y1 plus y2. So this is the law of additivity. And next is law of homogeneity. That means if it is multiplied by a scalar function a, then the output also multiplied by the scalar function a. So if it is multiplied by the scalar function a, then it should be multiplied by the same scalar function. So this is completely the superposition principle. Now if a system is obeying the superposition principle, then the system is said to be linear, otherwise the system is said to be non-linear systems. In non-linear systems doesn't follow the superposition principle and homogeneity. Now the linear systems do not exist in the practice, and non-linearities are caused by hysteresis, saturation effect, backlash, dead zone, etc. Now nonlinear systems are usually difficult to treat mathematically, and there are no general methods for solving the nonlinear systems. However, in the deviation from the linearity is small and considered to be insignificant for the problems, and in such cases the nonlinear system can be approximately linearized about the operating point. So in this lecture we have discussed the different type of the control systems, and the main difference is there are two types. There is the open loop control system and the closed loop control system, and the advantage and disadvantages of the open loop and closed loop system with the examples. So the basic difference of open loop and closed loop is the presence of the feedback. So next we will discuss what are the effects of the feedback. So feedback is present in closed loop system, and the transfer function and the closed loop system representation is, this is the reference input, and this reference input is fed to the controller. Output of the controller goes to the process of the system or plant, and the feedback is measured by the sensor. and the difference between this reference input and the controlled output is known as the error signal. So this is the error signal. So this is the complete closed loop system. So what is the effect of the feedback in this system? So next we will discuss the different effects of the feedback. Now in feedback control system is an operation in which the output is sampled and proportional signal is feedback to the input. The feedback output may be in phase or out phase with respect to the input. When the feedback output is in phase with the input, then it is called the positive. And this is actually the summer, and the output of this summing point or summer is the algebraic sum or the difference between the different inputs coming to this summing point. So if the input, if the feedback is positive, then we will put the positive over here and the error signal will be summation of this input with this input. And if we use the negative signal, then we will use the minus over here and the error signal will be difference of this input minus this one. So when the positive signal is used, then the output gets added to the reference input and increase the error signal and drives the output to the instability. But sometimes the positive feedback is used in the minor loops in the control system to amplify the certain internal signals or the parameters. And throughout this session, generally we will use the negative feedback in use. So what are the different effects of the feedback? So first, the effect of feedback on the overall gain. Now, if we consider a open loop system with the transfer function GS, when it is open loop, that means the input is RS. Actually this is in time domain, that is RT, and when it is converted into Laplace domain, then it becomes RS and the CS. So in open loop system, the transfer function is, or open loop gain is GS, and in feedback, if we use, this is in S domain, that is RS, and also it is in S domain CS, and the feedback is HS, then the closed loop transfer function becomes GS by 1 plus GS into HS. So if we consider the negative feedback, then the denominator becomes 1 plus, and if we use the positive feedback, then the denominator goes 1 minus GSHS. So for the negative feedback, the gain is reduced by the factor 1 by 1 plus GS into HS. So actually, due to the feedback, the overall gain get reduced. However, the gain can also be increased by gain amplification. So this is the first effect. And another effects, due to the using the feedback, the bandwidth may be increases. It reduces the effects of noise and disturbance of the system performance, and increases the accuracy of the system by reducing the steady state error, and also it stabilizes an unstable system. Also, it reduces the sensitivity to the parameter variations, that is makes system insensitive to parameter variations. That means if any disturbances are applied to the system, then the output will remain unchanged. So these are the important effects of the feedback in the closed loop control system. So guys, in my lecture 2, I have completed the different classification of open loop and closed loop control systems, the advantage and disadvantages of these two, the examples between this, and the remaining classifications also, and the effect of the feedback in the control system. So hopefully this is clear to you, and if still you have any doubt, then you feel free to mail me in my email ID. So thank you.